Do you have a USB stick, or should I just swap?
Swap these,
Okay. Sometimes I do love software magic. Sure. So, yes, I'm going to be talking about software-defined radio. Who's heard of software-defined radio? Okay, this may be boring. This may not be. We'll see. What is it? Why should you care? And the really simple thing about it is, yes. Hi, I'm interesting. My name's Derek, by the way. So it's a radio in which most of the functions are moved from hardware into software. And if there's one thing that we know about hardware that was especially outlined in the talk about the badges, hardware takes a long time to develop. And once you've developed it, you really don't want to change it because it's expensive and all that. Software, on the other hand, you just recompile it. You're like, oh, I forgot that. I'm going to change this constant, recompile, and run again. And so when you've defined a radio that way, that means you can just download a new modulation scheme and start instantly transmitting or receiving that. And what that means is there's a lot of free software out there that can do this. There's a lot of other things, commercial suites and stuff like that. And yeah, basically this is an example of a radio frequency coming in. And in hardware, you'd have to actually build out the capacitors, build out all the stuff to demodulate it. In software, some of these suites, especially GNU Radio, just block diagrams. You're like, I want an FM receiver. Click, drag, run. Awesome. So yes, this is, the 101. So signals. You have analog signals, which is what the actual entire world is. And you need to convert them into digital because your computer, unfortunately, doesn't store analog values. So an analog signal is defined for all possible times, and a discrete time signal is only defined for certain, usually regular intervals. And what this ends up looking like is you have a continuous thing coming in, and you sample it. So your sampling rate is one of those critical, things when you're looking at a software-defined radio. You end up with a whole bunch of different sampled values. And there's a whole bunch, so you have these values, and now you have to figure out what was the original signal that this represents. And so for each timestamp, you have a value, and the more bits that you have in your analog to digital converter, the better the resolution that you get, the better that you can figure out what the original signal was. So, more bits, better is the takeaway from this slide. And who can play connect the dots? What have we got here? Just shout it out. Sine wave. Looks pretty obvious, right? It's going to be that. Oh, wait, but it could be that. And it could be that. So this is called aliasing, and you have to sample at least twice as fast as what you're expecting to receive. And so what this comes down to is generally what they do is they put in a great big filter that enforces this rule, and that way you're no longer having to just go, it might be, it might not be. You know that what you're receiving is going to obey this law. And so what this means is you have to be sampling fast enough to receive whatever signal you're interested in. And for voice, this is usually about 1.6 kilohertz if you're transmitting like via one of the radios. But it can be quite a bit wider, or it can be quite a bit narrower, depending on whether you're doing like Morse code or digital mode, or you're trying to transmit, LTE for your phone is what, 20 megahertz wide, I believe, at least in some configurations. So this is what an SDR looks like. And it's basically an antenna, and then there's some mixing so that you can extract lots of information about the signal and accurately get the representation back, getting the amplitude and the phase and the frequency all in one go. And you filter, and then you convert analog to digital. But some of these SDRs, you end up plugging in via an audio cable. And so we call this a sound card SDR. And you're letting your PC do all the work. So these tend to be a lot cheaper, and you can get these quite cheaply online. Yes, receiver architectures. If you're a radio buff, you already know this. If you aren't, there's probably no point in me explaining this. Sorry, I should confess that I am remixing a slide deck that I already had. So this is what it's actually really quite cool. You're receiving a whole bunch of FM radio stations. So here we've tuned into 105.3, and you can see there's a signal here that's peaking. And this is what it actually looks like when you're receiving an FM broadcast station. Now, what's quite cool here is you can actually see it's starting to decode the radio data stream service. And so you can see it's decoding the information that normally you'd see displayed on your car stereo. And that's actually these sidebands here is where all that digital information is conveyed along. So you can see it's a very graphical environment. It's very intuitive to work with. You know, you can tune across. You can see how big should we filter this. And so many, many more radios are being built this way. Bandwidths of common modes, I've kind of already said, they vary. You have to be sampling at least twice as fast as whatever the bandwidth is here. And this is what I want you to all go away and buy. It's about 10 pounds, 15 pounds, comes with an antenna, and you just plug this straight into your PC, laptop, Raspberry Pi. There's lots of libraries for dealing with it. And this handles all of the converting into digital signals. And yeah, it's originally a TV tuner. And somebody found out that if you poked the firmware just the right way, it would send you the raw stream. And it receives from about 50 megahertz to 2.2 gigahertz. This varies depending on which exact model you get. Some of them will even go up and hit Wi-Fi at 2.4 gigahertz. Something fun in here, all of the cell bands are covered here. And while most of the conversations are encrypted, most of the data streams, you can pick up a whole bunch of the signaling and stuff and say, oh, a new cell phone's arrived, or somebody's receiving a call. And especially right around camp right now, there's the GSM cell network, and that's actually being run on software-defined radios. So all of the GSM work is being done on a completely off-the-shelf computer. It's an open source project called OpenBTS. So you could download this and be running your own cell service. You should have a license if you're doing this. Or you can do it in a basement very, very, very quietly. But go get a license. Or a metal shipping container. Totally legal if you're in a metal shipping container. To the best of my knowledge, I am not a lawyer, et cetera, and I'm American. It has relatively poor performance, but honestly, for 15 pounds, who cares? You can actually receive GPS. I don't know how. I don't know why. Magic. Lots of magic. But FM, AM radios, pagers. So if you're near a hospital or something, you can actually read the pagers, or near some business which still uses pagers. ADBS is what airplanes use to report their location. So if you're near an airport or just have airplanes flying over, you can actually load up a free piece of software and trace the planes flying over you. Lots of good fun. Weather balloons, like they've been launching, you can track using this. Satellites, yes, you should go and buy one of these. They're a lot of fun, and yeah, they're like 3 coffees, so go do it. This is the expensive version. It's like $600, 400 pounds, or more, but very, very flexible, much higher quality, and you can digitize lots of stuff at once. So you could be receiving 30, 40, 50 different voice conversations simultaneously if your computer will support it. And sound card interface. If you are already an amateur radio person or already have a scanner, you can often just connect an audio cable from this to your computer and get started with this software. I think, yeah, software. If you type in SDR or software-defined radio software, it'll just pull up this list for you. I'll also see if I can get get these slides posted somewhere on the wiki or something. But these are all free, and they're kind of going. SDR Sharp is about the simplest one you can download. It does run cross-platform. I don't know about Mac, but interesting. On OS X? Explicitly don't know X. Yeah. Well, grab one of the older versions then. It does work fine. SDR console is really nice. I believe it might be Windows and Mac only. HDSDR is fully open source, as is SDR Sharp, actually. Sounds like something really bad happened recently. GNU Radio is open source, and it's cross-platform, and it's actually the most powerful one. And that's what a lot of universities use for research, but you can just download it. And there are reasonable guides online, which I think I have coming up next. So this is what GNU Radio looks like when you download the graphical companion. And you can see we have a signal source coming in, and we filter it, and we look at an FFT, which I think is just the waveform that we were seeing before, showing the intensity over frequency. Low pass filtered again, simple squelch so that we don't hear just shh all the time. Do a narrow band FM receive and output out to the sound card, and you can receive FM radio. And so again, that's what that looks like. And this is the FFT down here, so you just get the nice output, and you're listening to radio. It looks complicated, but you can use it with one of these tiny little 15-pound tuners. It's a great way to get started. And you can listen to all sorts of things. YouTube videos. Yes, there are lots of YouTube videos covering GNU Radio, covering the RTL SDR tuner, which is the little cheap tuner. There's lots of resources online. And it's just going to get bigger and bigger and bigger because hardware is expensive to modify, software is cheaper to modify. Resources, yes. More resources for getting started with signal processing. So if the concept of discrete time and continuous time signals was completely new to you, these top two websites completely explain it. There's a free textbook on digital signal processing. And then this is a dead tree book. But it's excellent. You can pick up used copies very cheaply, and it's good fun. Thank you very much, and I hope people are interested in software-defined radio.
Cool. Thanks, Derek.